Hello and how are you? My name is Amir Sharafi. We will talk about wireless roaming today. I'm a Cisco wireless network trainer, Cisco certified network trainer for Cisco over 23 years, and for HPE, Aruba over many years, and for CWNP. And it is my pleasure to talk about different types of wireless roaming, and we will see from the beginning of wireless roaming process what is going on, how can we improve the wireless LAN roaming to make it seamless, to make it better, and so we will go and understand the frames and the different standards like 802.11r, 802.11k, and 802.11v, and so on, to understand how can we configure our wireless LAN controller and access points in our environment. How can we set up the environment from the beginning of the design, from the planning, from the site survey process till the configuration and operation, and during the troubleshooting and during the optimization process. It is important to understand the wireless LAN roaming and how it works. Okay, so let's go ahead and talk about the seamless roaming, how it works. So the point is that the wireless client, it wanna be connected to a wireless environment without any interruption, without any reconnection with a time gap. This is the point, because the most application, the mostly of usually applications we use, if they are UDP or TCP applications, especially today when we use more and more video conferencing systems, voice over IP, and all other time critical and time sensitive applications, it's very important that the roaming process, that the roaming time, it's a very, very quick and very, very smart process. For this reason, we will go through the different type of the implementations of the roaming process. As example, I will talk about two different type of roamings, what we can use here, and I will go deeper and look at the autonomous controller-based as a intra-controller roaming, as a inter-controller roaming layer 2, as an inter-controller roaming layer 3 with a tunneling, as a auto-anchor tunneling, and these are solutions which are provided by a lot of companies, for example Cisco systems. And we will also talk about the other very smart solutions which is, for example, provided by the company HPE Aruba as a multi-zone, which is a way how can we provide the roaming or to delivering the special SSIDs to special dedicated wireless LAN controller. Okay, so let's go ahead. So normal case, when we talk about the roaming, we have a connection between the first connection between the AP and the client, and the point is the attempt to be connected, it is always started by the client. The client is the guy who starts to be connected to a wireless access point, to wireless association point, or a wireless access point in this example. and the decision of the roaming, at which time I want to change my AP, or the client want to change the AP because it is going far away from one AP. For example, in this case, the client is here and is moving that way, yeah, to that AP. The process is a process which is mostly done by the drivers, by the client, by the drivers of the wireless adapters of the wireless clients. It can, if it is a smartphone, it is a tablet, it is a barcode device like a Zebra. For example, it is a regular notebook or laptop. The decision is done by the client. How does the client makes the decision of the roaming, of the changing? Why the client will go far away from that point? For example, the client is connected to the AP here and wanna walk in that way, and at some I would say some area, some coverage, some area, the client will recognize, okay, the signal to the connecting AP, it get weaker, okay, and I can hear, I can listen to some different APs around me. They have a proper signal to be connected to, and this decision, at which point the signal is low enough to start the roaming, and at which point the signal is high enough to be connected without concerning about, okay, I want to roam. I am connected. It stays stable connection. I don't need to roam. It's like a low watermark and a high watermark. And this is a point, this is a dBm or RSSI and signal noise ratio. All these values could be changed in a drivers of the wireless adapter. Okay, it means the wireless client and wireless adapter, they have a very, very important task to do. It's the role of the wireless adapter is very important in this case, because some people, they believe that the decision of the roaming, it can be done by the AP or by a wireless LAN controller. Okay, we can have some, because of some standards or some protocols, we can have an influence. We can make an influence of the decision of the client. But finally, the decision is done by the client. Okay, it's very important to know this. When we have an autonomous environment, it means each AP had its own environment, each AP had its own image or software, and the connection between the client and the AP, it is like a autonomous, it is a standalone decision. In this case, there are some smart solutions which over the last 20-25 years from the different companies like Extreme and Rakas and Cisco systems and go on, they have some smart solutions which try to make the roaming even better, and we didn't have in about the year 97 when we got the first wireless standards, and 99 the next wireless standards, and it later we got the standards like 811N and AC and AX, and soon we will have the Wi-Fi 7 802.11 BT. So what is going on now? We have standards which really are a support for the wireless environment, for the wireless and network staff, to prepare the seamless wireless roaming. And these are standards which is supported, they are implemented in the adapter software and adapter drivers of the clients, which make the roaming much better. So we are far away from the time without any roaming protocols till we had some roaming protocols, but very proprietary from the companies which did have their own solutions, which really proprietary. But now we have standards like 802.11r, yeah, with a fast BSS transition, or 802.11v and 802.11k, and so on, which make the roaming much quicker and much smarter. So let's talk about this. So in the case we have the wireless LAN, for example, we could have here a wireless LAN controller. It could be one device, it could be a cluster, it could be an HA, high availability, as a pair. In this case, the resources for a wireless, the connection, the first attempts, like the probe request, probe response, the authentication, the 802.11 authentication to the APs, and the later the association and the next steps of the authentication, they are done, they are organized by the wireless LAN controller, the most deeply security processes like 802.1x, if we have one EAP or EPOL method, like we have EAP-TLS or protected EAP or EAP-TTLS, whatever. It is organized by the wireless LAN controller. Okay, by the way, so of course we have the AAA server, radio server in the background with the AD, with all these stuff. We will talk about this a little bit later. But the APs, the APs are managed by one, I would say, one single device, one single instance. In this single instance could be 2 or 3 different hardware modules, which are as a cluster, but from the view of the client to the AP connection, it is, I have here one instance which is responsible, which is controlling the connection of the wireless client. Okay, so for this reason, it is the very quick and very smart, very quick roaming. It is the first. I will show you. Let me go through the. Let me show you the wireless client first connection. The wireless, when the wireless client gets the first connection, and it has its first after the probe request and probe response to the AP, it starts the 802.11 first authentication to the AP, and then it goes to the association. Yeah, and then after the association, it is up to the which type of security or which security implementation we are using. For example, in the case, it could be what we see here. It could be a web authentication with the captive portal. So the client could go after the authentication and association. The client can go in a layer 3 process and can get through the DHCP process, gets the DHCP IP address, and later with a captive portal DNS redirect, we will go and authenticate the client. But the point is, what will happen at this moment, what will happen with the client when we go, just a moment, we go here and see the client, here at this part, we see the client goes through the authentication, and then it has a reassociation. And for the reassociation, it means the client was connected to a AP, and now the client will go and be connected, like can be connected to the next AP. It means through this process, the client will walk, and from the AP to the next AP to the next AP will try to connect. So what we can do to prepare our environment, to prepare, we can prepare the access points, something like I pre-authenticate the client. It means for some of the authentication processes like 802.1x, which is a whole IP exchange between the AP to the controller to the EEE server, to the radio server, it needs a long time. So we want to speed it up. For speeding it up, there are some smart ways to do it. For example, we have some opportunistic key caching, so we can make the APs to cache some very important credential, so that before the client start the whole process with the environment, the AP is prepared, the AP is ready. So we will reduce the roaming time, okay? And for this we have, for example, the fast BSS transition. What is 802.11r, which is as a standard, which is implemented in the most, I would say, the most wireless clients today. And the process goes that the client will, during the first connection to the AP, will exchange which type of the standards do I support, which type of the standard do you support. So it means the AP is aware and knows, okay, the client can support 802.11r or 802.11v or 802.11k, for example, for assisted roaming or for radio resource management, exchange of the information, which the AP can, for example, send in neighbor information, which APs are in the environment which have good resources, and which the channel list can be distributed, and so the client can be prepared, can get some information from the AP. So it is not a surprise for the client, or it's not a surprise for AP when they get, during the roaming process they get the first contact. Because before, when we have our client here, and the client goes in that way, and has the first attempt, the first contact to the AP, it is very useful that the client knows something about the environment, something about the load, something about the radio resource information of the environment, and the AP also knows useful information, can cache some useful information about this client, and let the client be roamed very quick without going through the whole authentication process. Okay? So let me talk about the next step. Let me talk about the first intra-controller roaming. What is intra-controller roaming? Intra-controller roaming is a process which is really nice. We can build from when we have a multiple controller like that one or that one, which are different instances, and each controller has its own client database. It means for example, the controller 1, it doesn't know about the clients which are associated and authenticated to the controller 2. Okay? It has its own database. Okay? It knows about its own the clients which are connected to him, so it can store all these information. It is database. So what we do here is a very smart thing, that we share information. So we set up something, for example, in the case of Cisco, it is called roaming improvement. With here we build a special mobility group or mobility domain. So what we do, we make the controller, we let them exchange the client databases, the credentials, the security informations. So after the exchange, it is, of course, it's very important to know what is the maximum supported entries in the security database of a controller. Okay? For example, if we have a controller type which can only store 32,000 client entries, okay, and it has its 32,000 client entries, so in the moment we build a mobility group or mobility domain, so maybe the neighbor controller, it has an entry of 20,000 client entries, which are here connected to that guy, to that guy. So the problem would be, during the exchange process, we will get some buffer overflow, we get some really memory problems. So we have to be aware about the maximum number of the clients which are, or client entries which are not locally connected. For example, we have a campus, and the campus, the controller on this side, the controller, it's in the building 1. The controller on this side, it's a building 2, that one. So, and between the both controller, maybe we have a mesh installation. Yeah, wireless mesh for outdoor. So the clients could be in a conference room here. They can start a call, and then they can walk down, go through the campus area, and can be connected to that controller without any interruption. Okay? Without any new authentication, and without any time gap or delay because of the new authentication process. The experience of the most network engineers and the experience what we have for this type of intra-controller roaming layer 2, it is something, the maximum of a roaming delay is something about 10 till 20 milliseconds. Okay, it's very quick. What is the condition of this type of configuration? It is very important for this configuration type, what we see here, that the of course, the SSID name must be the same, of course. By the way, the SSID name, or the SSID, the WLAN name, they must be always the same. It doesn't matter which type of roaming we want to configure. Intra-controller, inter-controller, layer 2, layer 3, whatever, the SSIDs must match. Okay? And the other thing which is very important to be aware is not only the SSID, it is the security configuration must match. And I would prefer, or I would recommend, to take care of additional configuration of additional features like a quality of service, like which standards are supported, like you have a support of 802.11r, 802.11v, 802.11k, and something like if we have a protected management frames like 802.11w. So, and it is in our configuration, it is a mandatory configuration. It should match the configuration here and there. It could happen if the protocols, if the configuration, if they are not matching. So it could, of course, it could happen that during the roaming process that the client is disconnected. Okay? What is important to take care about in a layer 2 configuration, intra-controller layer 2 configuration? Okay, the same SSID, of course, but the same VLAN. The virtual LAN should match on the both controller. If you are using for a SSID guest VLAN number 20, you should configure the same VLAN number on the other controller. The configuration of subnet mask, default gateway, and the network TCP/IP stack, it should match also here. If you have a network configured here, for example 192.168.1.0 with /24 for this SSID for this VLAN, it should have the same network here. So what will happen, the client gets an IP from that stack, from that IP version 4 or IP version 6, doesn't matter. And when the client moves to the next controller, the client will keep its IP address, and the connection of the client to the destination, for example, the client want to send some packets to internet or to the file server, the connection before the roaming goes, for example, through that controller. And when the client makes the roaming, during this process, the roaming process, the wireless roaming process, the association and authentication process will be redirected to the controller, and the controller, the new controller, will send a special client handover request to this controller. We'll ask him, hello, your client is knocking on my door. Can I let him in? And it is a process which can be done, which can be successful when the controller are in the same mobility group, and all the ports what we use for a controller, they are here they set up right. For example, the mobility port, UDP port for communication between the controller, because the controller they exchange all these data, for example, over the UDP port 16666 when we have a Cisco system connection. Cisco uses the UDP port 16666 for the control frame exchange, database exchange, and later for a special tunneling of a client traffic, it uses Ethernet over IP port, for example, 97, which should match. Okay, this is one. Let me go to the next one. This is a layer 3. The layer 3, it works different. Why it works different? Because when the client is connected to the first controller, which is called anchor controller, yeah, or the first step controller, when the client moves to the next AP and attempt to the new controller, hello, I want to be connected, the new controller, it will not register the client as we saw in the layer 2. It will tunnel the traffic to the first controller. It means this new controller for the client is a new controller, is something like a foreign controller. It will just retunnel the client traffic to the original controller where the client was connected. Okay? It means the connection between the AP and the controller, it could be in this case, it's a standard protocol, standard tunneling. We have a RFC protocol here, CAPWAP, which is used by Cisco systems. But other companies, like, for example, in this case, Aruba, they use a GRE tunnel. Yeah? And then, with a layer 3, intra-controller roaming, the very interesting, nice thing is, you can have here different VLANs and different subnets. Why it works? Because here your guest SSID could be connected, for example, to the VLAN here, VLAN number 20, but here to VLAN number 30. Here you can have an 192, 168 IP address of your network. Here you can have the IP address 172.16. It's a different network, really different network. So what will happen, why it works? Because when the client goes here through the authentication process, the client will keep the old IP address even if the client is in this new area, because it is like an IPsec or like a VPN. The client traffic will be tunneled back to the originated network. And it's a solution for those implementation where we have for example, campus, where we have an area and we have different VLANs, we have different subnets. It works, it's good. The roaming delay for this is about 20 till 30 milliseconds. It's a little bit more, but even okay. What is more, what we can use here, it's for when we candidate, we use a dedicated controller, dedicated controller. We put the controller in some area, for example, in DMZ, we set up an anchor controller there, dedicated for dedicated SSID. This is a solution for those customers who have, for example, different SSIDs. The enterprise SSID will stay here in the environment in my campus, and the guest SSID, my guest SSID, for example, the guest SSID, I wanna keep it away from my environment to some special area where I have intrusion detection, intrusion prevention, NAC appliances, some more policy enforcement, so I can really redirect it, tunnel it to that point. It works really good, and it is called guest access with mobility tunneling. Okay, so this is the solution of the HPE Aruba. Here in this case, we can have two different SSIDs too. For example, primary SSID and for example, data SSID. We can have a guest SSID, and one SSID can be sent to the primary zone and one to the different zone. So what will happen here is, from the view of the AP, this is a solution what is very special of Aruba. Aruba APs can set up different tunnels to different controller or controller cluster and controller environment. So they can send a special SSID to, for example, to one controller cluster, and other SSID to that one. Yeah, it is one idea what is comparing to the Cisco one. It is a little bit different, but it works too. Okay, there are the different, here I have some for you as a reference, some packet capture with a Wireshark. This is the first connection, reassociation, the WPA four-way handshake, first connection. As you see here, you have here at this place, you have here the association here, the first association, and then this is the reassociation here, yeah, and four-way handshake. Then we have the EAP process. It depends of which type of EAP we have. In this case, you see here we have a protected EAP, MSCHAP version 2. Here you see the EAP PEEP here. So it could be the process, the single steps of the EAP process could be different up to the type of the EAP what we are using. For example, in a case of a PEEP, protected EAP, we have only server side certificate. It is of course different compared to EAP TLS, where, for example, we have a mutual authentication with the server side certificate and the client certificate. Then we have additional steps. Okay. As a reference for you guys, the Certified Wireless Analysis Professional, this is a book as a electronic e-reader or as a paper book from the organization CWNP. This is an official study guide, and you can use this as a reference, especially if you go through all the processes of, for example, of authentication of all the packet capturing. You will have a lot of additional information. So, by the way, I have some additional information for you. If you want to read some more information about special standards, what we use, let me write it here down for you.